NASA finally opened the space capsule containing the largest asteroid sample ever collected by a space mission. The sample came from Bennu, a potentially hazardous asteroid that's like a time capsule from the early solar system. On 26 September 2023, scientists at NASA's Johnson Space Center in Houston opened the lid on the sample return canister from the OSIRIS-REx mission, which had returned to Earth 2 days earlier with a sample from the asteroid. As the lid was lifted, scientists gasped at what they saw: a layer of black dust and debris on the avionics deck of the canister. Also, the sample weighed 100 grams more than what was collected at Bennu. This was unexpected, as the sample was safely stored in a sealed container all along the way. So, how did this happen in the first place? What's the source of the unexpected black dust on the avionics deck of the canister? Finally, and most importantly, what do scientists expect to find in the detailed analysis of the largest asteroid sample that has ever returned to Earth? When the OSIRIS-REx mission was launched on 8 September 2016, it had 3 key goals. The first was sample collection. The mission aimed to collect pristine samples from the asteroid's surface, providing crucial material for scientists to study and understand the composition of primitive asteroids. The second was asteroid characterization. Astronomers wanted to know the geology of Bennu, and the mission was tasked to map the asteroid's surface, figure out its composition, and determine its potential as a resource for future space exploration. Finally, the third key objective was Earth's impact hazard assessment. As mentioned earlier, Bennu is a potentially hazardous asteroid. On 25 September 2135, Bennu will make a close flyby of Earth. Our planet's gravity will tweak Bennu's path, making it a challenge to calculate its future trajectory. That's because, in addition to gravity, asteroids can be pushed around by non-gravitational forces, like the Yarkovsky effect. When sunlight strikes a rotating asteroid, the day side heats up. As the asteroid turns, the night side cools down and releases the heat. This exerts a small thrust on the asteroid, which can change its direction over time. The Yarkovsky effect is challenging to model, but it can make a big difference in determining where asteroids end up. Because we don't know exactly how the Yarkovsky effect will perturb Bennu's orbit, we have limited knowledge of where Bennu will be as it approaches Earth in 2135. Scientists thus have to consider a range of possible trajectories, depending on how strongly the Yarkovsky effect is pushing on Bennu. A few of these trajectories line up with regions of space called gravitational keyholes. If Bennu were to pass through a keyhole, Earth's gravity would bend its path in just the right way to cause an impact on a subsequent orbit late in the 22nd century. The odds of this actually happening are quite low, but scientists want to know as much as possible. The journey to Bennu was a 2-year, 4-month voyage. On 3 December 2018, OSIRIS-REx arrived at its destination after traveling approximately 1.4 billion miles, or 2.2 billion kilometers. It entered orbit around the asteroid, initiating a series of surveys and mapping activities to select the optimal site for sample collection. The most thrilling phase of the OSIRIS-REx mission was the sample collection event, which occurred on 20th October 2020. The spacecraft used its touch-and-go sample acquisition mechanism, or TAGSAM, which briefly touched the surface to collect the sample. TAGSAM is a robotic arm attached to the spacecraft's main body that collects a sample from the asteroid and puts it into the Earth return vehicle. Since Bennu is a small asteroid with just half a kilometer diameter, the arm had to collect the sample in almost zero gravity. OSIRIS-REx had just one chance, and there was no margin for error. Finally, when the spacecraft made contact with Bennu at a site called Nightingale, a burst of nitrogen gas was used to agitate and lift surface material into the sample collection chamber. The minimum requirement of the sample size was 60 grams. However, in the brief 9-second contact with Bennu, OSIRIS-REx collected 300 grams of the sample. That's 5 times what NASA had anticipated. The sample was encapsulated, but an issue arose. The material was escaping due to a jammed flap caused by larger rocks. To avoid any more loss, NASA decided to skip the scheduled measurement of the sample and sealed it for return. OSIRIS-REx departed Bennu on 10 May 2021 and began its journey back to Earth. After almost 2.5 years, on 24 September 2023, the spacecraft reached Earth's vicinity and released the capsule containing the asteroid sample. The capsule entered our planet's atmosphere at a speed of 12 kilometers per second and deployed a parachute to slow down its descent. The capsule landed safely at the Utah Test and Training Range, where it was recovered by NASA personnel. A couple of days later, scientists at NASA's Johnson Space Center in Houston opened the lid on the sample return canister from the OSIRIS-REx mission. They were met with a sight that both surprised and excited them. The first thing they saw was a layer of dark powder and sand-sized particles on the avionics deck of the sample canister that likely belonged to Bennu. This dust not only coated the interior of the canister, but also extended to its exterior, including the avionics deck where the electronics were housed. The dust escaped from the canister through tiny openings between the lid and the body. The question that arises is, how did this happen? According to NASA, upon its touchdown on Bennu, OSIRIS-REx's brief contact is believed to have generated a shock wave that spread across the asteroid's surface, resulting in the expulsion of certain materials into space. Some of this material trailed behind OSIRIS-REx as it retreated from Bennu and stuck to the spacecraft's outer surfaces. Additionally, a portion of it entered the sample canister through the open flap, mingling with the material gathered by TAGSAM. The combined mass of the sample, including the dust and debris, measures approximately 400 grams, exceeding the requirements for their scientific goals. Furthermore, it's reported that the sample remains in excellent condition due to minimal exposure to high temperatures or contamination throughout the return journey. However, the presence of dust and debris on the avionics deck poses a unique challenge. It necessitates careful handling and cleaning by the scientists who employ specialized tools and techniques. They aim to remove the dust and debris from the deck without causing any harm to the electronics or losing any of the material. Additionally, they must meticulously document and catalog each fragment of dust and debris since they are integral components of the sample inventory. This sample return mission is a historic moment. But why are space agencies investing billions of dollars in visiting space rocks that are hardly half a mile wide? Well, that's because asteroids are time capsules. They formed in the early solar system when the planets were still forming. Asteroids comprise the same materials the planets are made of, but have not been processed by plate tectonics or other geological processes. This means they can preserve a record of the early solar system not found on Earth. For example, scientists have found that asteroids contain various organic molecules. These molecules are thought to be the building blocks of life, and their presence on asteroids suggests that the ingredients for life were present in the early solar system. The discovery of organic molecules on asteroid Yugu is a particularly exciting example. Yugu is a carbonaceous asteroid, which means that it is rich in organic material. In 2020, the Japanese spacecraft Hayabusa 2 returned samples from Yugu to Earth, and scientists have since analyzed these samples and found a variety of organic molecules, including amino acids. Amino acids are the building blocks of proteins, which are essential for life. This hints at the possibility that life's ingredients might have arrived on Earth via asteroids in its early history. The next phase of the OSIRIS-REx mission, now renamed OSIRIS-APEX, will focus on studying asteroid Apophis. Apophis is a near-Earth asteroid roughly 1,100 feet or 340 meters in diameter. It'll make a close approach to Earth in 2029 and is estimated to have a 1 in 150,000 chance of impacting Earth in 2068. OSIRIS-APEX will arrive at Apophis in April 2029, just a few months after Apophis's close approach to Earth. The spacecraft will spend 18 months studying Apophis from orbit. During this time, OSIRIS-APEX will use its instruments to image and map the asteroid, study its composition, and measure its size and shape. The OSIRIS-APEX mission is a critical step in our understanding of near-Earth objects and the threat they pose to Earth. The mission's data will help us better protect our planet from asteroid impacts. Recently, the James Webb Space Telescope revealed the secrets of Earendel, the most distant single star ever seen in the universe, lying at the edge of time. If you missed what Webb found out, make sure to catch up on this exciting discovery.